So let's look at how to use Excel to carry out a net present value procedure. So here we've got some information on a particular investment project, which is going to involve initial expenditure of 1200 on the equipment and then generate some net returns in the future years. What we need to do, of course, is to find the present value of the net amounts, add them all up, to find the net present value. If it's positive, then the project is profitable. If not, if it's negative, it's not. So the first step is to find the net return in each year. Now year naught, of course, means the present, and then we've got another 8 years of potential returns. So I'm going to find the net return here by working out income minus expenditure. So let's do it for the first year, for year naught, for the present, when, as I say, it's negative, because in this is the when you'll actually be purchasing the equipment, investing the money. So if I now copy down, it'll do all the rest. So what we find here is that in future years there'll be extra revenue generated from using this equipment. There'll also be some additional operating costs, so the difference is the extra profit that's been generated. Initially, that's in year one is still negative, but then as the machine becomes more and more productive, as it's brought online, the returns increase. Then towards the end of as the machine depreciates and towards the end of its life, the returns fall again. So this could be a fairly typical case. So now we have to find the present value of these sums using a particular discount rate, which is over here. So I'm assuming at the moment that this is 7%. This, of course, represents the opportunity cost of this expenditure. It's what you could get, it's the interest you could get if that 1200 was simply invested in the next best alternative. So we're looking for this investment here in this equipment to generate more than 7%, which is what the net present value technique determines. Now, to find the present value, of course, of a future sum, you use the formula here. It's the future sum, S, divided by 1 plus R. R is the discount rate, raised to the power of n, n being the number of years in the future. Now we're assuming that any interest here is levied simply once a year, so there's no need to include K here. K, of course, represents the number of times that interest is compounded. Here it's only once, so we have the slightly simpler version here of the present value formula, which is in your handbook. So let's put the first one in here. So we've got the amount divided by 1 plus the interest rate, the discount rate. Now remember, of course, that if I'm going to copy this formula down to do the rest, then I must, of course, make H2 absolute so that stays at H2 where the discount rate is. Obviously, I want the numerator D2 to change for the different net returns. I also want N, the year, to change as I copy down, but I don't want R to change, the cell in which R is. So I need to fix H2 absolute. Now to do that, of course, we put dollar signs around, and a quick way to do that is to use the F4 function key. Now I can raise that to the power of n, which initially is 0. This is in year naught. And of course that simply gives me 1200 again, because the present value of an amount in the present is of course the same. It works, of course, because we're raising this to the power of 0, and as you should know, anything to the power of 0 is 1, so we're simply left with the amount 1200. Now when I copy the formula down, S will change accordingly to these, N will change accordingly to these, but R will stay as it is at this 7%. So let's copy this down here. So those are the other present values. Let me just reduce them to, say, 2 decimal places. Which is sufficient. Probably rounding them to whole numbers would have been okay, but I'll leave them at 2 decimal places here. So these represent, of course, the present value, which is the amount you'd have to invest today at 7% per annum to generate this future sum. So if you wanted to end up with 595 return in 4 years' time with a 7% interest rate per annum, you'd have to invest £454 today. Now all we need to do is to find the net present value, which is the sum of the positive returns minus the negative ones, which means, of course, we simply add up all these values. So let's use the sum function as always. There we go, just check that we've got the right range, E2 to E10. So that will give me the net present value, which is currently negative, which means, of course, that this investment project as it stands is not profitable. These net returns are not sufficient to outweigh the cost when you take into account the return that you could get on the next best alternative. Now, of course, if the discount rate was lower, if the interest rate that could be got on the next best alternative was lower, then this would change the calculations, and in fact this net present value might turn positive, meaning that this is a worthwhile project. The beauty, of course, the advantage of setting up in a spreadsheet with formulae is that I can simply change the interest rate here and it will recalculate it and we can see the impact. So let's change it to 6%. So 0.06. That recalculates. It's still not quite profitable here. Let's charge 5%. So let's try 5%. Nope, still not profitable. Let's try 4%. Okay, so as you can see, if the discount rate was lower, discount rate, remember, represents the return you could get on the next best alternative investment of your 1200. Then at this lower rate, of course, now the investment does seem worthwhile. It is profitable, and in this case you'd go ahead. So clearly the interest rate is a crucial factor here. Okay, so that's how to do net present value calculations.